Okay, good morning, everyone. Is this working? Yeah, you can hear me over the speaker?
Yes.
Okay, great. Well, then I appreciate everyone getting up halfway early on a Sunday morning to listen to things that I may or may not have to say. My name is Harald Welte. I am a free software developer for, I don't know, as long as I can think. And I've been doing all kinds of work in Linux networking, Linux kernel networking. In the past, I have been one of the authors involved with the netfilter IP tables packet filter that some of you may use, some others may not. And in recent years, something like the last 5 or 6 years, I've more moved into mobile communications. So away from the internet and TCP/IP and Ethernet and things that people in IT normally consider networks, moved into mobile communications, which is a completely different area, of course. And in mobile communications specifically, I have been working on the various protocol stacks that are used in mobile communication systems, which are completely unlike TCP/IP. So those protocol stacks are highly specific to, let's say, the GSM mobile telephony system or any of the other systems that people use out there. And as part of that, we have created a project which we call Osmocom, which means Open Source Mobile Communications, Osmocom. And it's an umbrella project that includes many other projects about different parts of mobile communication systems. And this talk is an introductory talk, an overview talk about the different projects that exist below this umbrella or under this umbrella. And I'm also going to be covering a bit of the history that led us to where we are with those respective projects. So, as I said, my origin is network security, and if you're doing some kind of research in network security and it's related to internet or TCP/IP protocols, then it's relatively easy if you want to do that. All you need to do is you get some off-the-shelf hardware, like any random laptop. You start with an open source implementation of those protocols, and BSD and Linux and many other implementations of operating systems contain a TCP/IP protocol stack. Then if you want to modify something, it's source code, you just modify it, you recompile it, you run it, and then you can try your new ideas. Let's say you have an idea about how do systems react if there is a message incorrectly formatted, or or you have an idea about how you can optimize performance or whatever it might be. You just go there, you take a random PC, and you modify the source code, you recompile it, you run it, and that's basically what you do. If you work in a scientific area, then you write a paper, you release that paper, and publish the results, and that's basically what you're doing. That's the kind of background that people expect when they do research in networking technology. Now, if you want to do that in mobile communications, it starts with a very simple fact that there is no equivalent of an Ethernet card for mobile communications. There's basically no device that you can buy which gives you layer 2 access to the medium, to the protocol stack. If you want to use a mobile phone, then that implements the entire protocol stack, sometimes 7, 8, 9 layers deep in proprietary software, and you can send messages above that stack. But you don't have a simple transceiver interface like a Wi-Fi card or like an Ethernet card that gives you physical level access to those protocols. So if you want to do something analogous to what I described in the TCP/IP world in mobile communications, then before Osmocom projects came out a couple of years ago, you have the problem that, first of all, there is no hardware available that gives you access to the physical interface. There are no free and open source software implementations of those protocols, so there's nothing that you can modify in order to try a new idea because, well, it doesn't exist in open source software. And then, well, you can either turn away at that point and say, well, it's just too hard, or you can actually try to build the entire environment that you need, including maybe the hardware required and including the free and open source implementations of those protocol stacks. Also, if you look at mobile networks, there are very, very few universities who have, let's say, their own GSM network, their own base stations, their own MSC and whatever other components of GSM networks or other mobile networks. Because the equipment is very expensive, it's very large. I know a university in Brno in the Czech Republic who has all that equipment, and I think they paid 300,000 euros some time ago on all that equipment, right? So it was only possible because there was some very large grant, but it's very expensive, very large equipment. And then even if you buy that equipment, it's black boxes, right? It's not that you can, as a student or researcher, you can actually go and make lots of changes. It's a black box. You can change some configuration settings, but you cannot really explore and modify the system in any way. So the only way you have is you partner with one of the commercial companies that have the technology, but then you're under some NDA and you cannot release your results and so on, and it's basically a locked-in situation. Now, another observation I'd like to make is that both the specifications are completely public. So if you want to learn about TCP/IP and the internet, you just read the RFCs, you read a couple of textbooks, and all the information that's out there is there. You know, it's not, you don't need to pay a membership fee, you don't need to pay for specification documents. You know, the limitation is only the capacity of how many documents you can read. But there's no limitation that's, you know, monetary or economic or something like that. The same is true for the GSM and 3G and other mobile communication networks, which many people don't know. All the specifications are public, they're all out there, they're all freely available, and free as in free beer, not under a Creative Commons license, so you cannot edit them or something, but you can download them without having to pay any money. So anyone who wants to learn and understand those systems can actually, or even implement the systems, can access all the required information. There's no secret sauce involved. However, if you look in the scientific world, for example, the amount of publications that exist on, let's say, TCP/IP optimizations or research or security, and if you compare that with a GSM or mobile communication networks, then you will find, I don't know what the factor is, maybe a factor of 1,000 or something like that in difference in terms of publications in those two areas. And it's simply, again, because, well, you cannot get access to the required hardware, there are no free software implementation, and everyone who is able to do research, in the end, is basically the 4, 5, 6 companies who have their own implementations of those protocols, but nobody else is able to innovate in that area or to do some development. So there are only very few closed source implementations of those systems, and the companies in possession of those are not really in any way interested in changing that situation, of course. So if you look at the handset side, the mobile telephone side, then there are very few companies that build the chipsets which are used for accessing these mobile communication networks. I'm not talking about the application processor where your Android or your Windows Phone or your iOS runs on. That's the 9 to 10 to 12 layers above all the things that I'm speaking about. So the application processor that runs your user interface and that runs your Android or your iOS and so on, that's nice and okay, well, that's one part. But there is an equally complex other processor in the phone, which is called the baseband processor, which is implementing all these communication protocols, which interfaces with the radio and which talks to the communication networks. And there are very few companies that build these. These processors, we are not talking about some small microcontroller with a little bit of firmware. We're talking, in modern phones, we're talking about an ARM11 processor with several hundred megahertz with something like 48 or 64 megabytes of RAM and an equal amount of flash plus operating system and so on. So you have a very complex system that's completely independent from your application processor, where you run your user interface and your apps and all that. You have a second computer inside, and that's the one I'm speaking of. And there are very few companies, and the operating systems and everything that's in use there, from the OS to the protocol stack to everything else, is proprietary. And even the phone makers, so let's say a company wants to build a mobile phone, when they buy the chip, even they don't get the full source code to all that stuff. So they just get some libraries and a little bit of source code for whatever is necessary for them. So they have limited access. And also in terms of documentation, they don't get the full documentation about those chips. Only the chip manufacturers have these. So it's an extremely closed environment. If you look at the network side, it's the same. If you look who builds base stations for mobile networks, there's Nokia Siemens Networks, there's Ericsson, there's Huawei, there's ZTE, there's, well, Alcatel-Lucent, not so much anymore. But it's a very small group of companies that build devices for that market, and their only customers are operators. So even if you have the budget, even if you have those 6-digit euro amounts to be able to buy the equipment, they won't sell to you because you're not an operator, and they only sell to operators. And they are not even interested in selling you, 2 base stations and a mobile switching center, because they want to sell you 10,000s of them. And if you're just such a small company or such a small customer, they're not interested in even selling to you. So it's really difficult to buy such equipment on the network side. So that's equally strange. And if you look at operators, well, then I'm not sure how it is in Bulgaria. I cannot make comments on that. But at least in Germany and other European countries, in our neighbors, operators are mainly banks today. Operators are not technology companies. Operators outsource network planning, network deployment, network operation. They outsource basically everything. And what remains is a bank that is able to make investments. They even outsource the billings. So even the generation of the invoices, and I'm not just talking about the printing, but the actual computation and so on, everything that goes with it is outsourced normally today. So what remains is very, very few people with technical knowledge. And actually operators state that. I work for operators, so several operators, and I quite often hear the statement, yeah, 10 years ago we still had people who understood all that technology, but they're expensive and senior people and they cost a lot of money, we had to let them go. So that's the situation. So we have operators that don't really understand much about technology, and we have very closed companies on the handset and on the network side. And that's sort of the environment that we're in. Now, why would it be interesting to do some research in that area? Well, because if I speak about security research, most people think, oh, it's about listening to other people's phone calls. Well, okay, that's nice, but it's not really the point that I'm trying to make. There are many more things that happen on mobile communication networks which have quite some impact, and which is not just listening to a phone call between me and my grandmother. So the machine-to-machine communication. Like all modern BMW cars have GSM modems inside, which can be used to open the doors or to block the engine or something like that. Yeah, it's true. I mean, it's there. Right? There are burglar alarm systems that often report over GSM. So if you can attack the security of the system, you can suppress such alarms from being made. Smart metering is a topic that's under a lot of discussion, where the report of how much electricity you consume is transmitted over mobile networks again. If you can manipulate that, of course, there's things associated with that. Very dangerous, GSMR, railway GSM. It's a system that Europe-wide is used for communication between trains and train operators. And there is an unencrypted and unauthenticated message in that system, unconditional emergency halt. If you can implement a GSM network site, you can stop trains, And vending machines, let's say there's a vending machine for selling parking tickets or something like that. Often, if their coin box is full, they send an SMS over GSM to whoever is supposed to be emptying that box. So if I'm a thief and I want to crack that box when it is full, I can intercept the communication and I know exactly, oh, now the coin box is full, now it's most efficient to break it open and steal the money. There are wind in Germany. Wind power is very how can I say the big trend right now is to have lots of windmills to generate power. Quite often, they are in remote areas, and somehow you need to control if they should currently inject power into the grid, or if they should not inject power into the grid. And what do they use? They use GSM to remotely control those windmills. So what I'm trying to say is security of these mobile communication networks has implications far beyond confidentiality of voice communication or voice calls that people make. Right? Transaction numbers for electronic banking, I'm not sure how it is here. In Germany, a couple of years ago, we had lists with transaction numbers. And every time you make a transfer on using internet banking, you go to that piece of paper and you use one of the transaction numbers that are printed on it. So it's like a one-time number that you use every time. Now today, the banks, or a year ago, 2 years ago, the banks stopped doing that and they send you the transaction number over SMS instead. Now, who can intercept? Yeah, who can intercept GSM gets the transaction number. So is that an improvement in security over a paper? No, it's clearly not, but people do it because they think mobile communication networks are more secure than the internet, but in reality, it's the other way around. Internet is much more secure. Right? On the internet, nobody would do anything security critical without using an SSL connection in the web browser or without using a VPN of some kind of sort, right? On mobile networks, the encryption is like 15 years behind that what people do on the internet, right? When was the last time you have used a web browser that used a 64-bit encryption or a 40-bit encryption? You know, that was in the 1990s. But if you make a voice call over GSM or if you send or receive an SMS, it is a 64-bit cipher that is being used right now. Right? It's not AES 128, it's not AES 256. No, it's something that's worse than AES in terms of security, and it only has 64-bit key length. So it's an entirely different situation. So anyway, just trying to describe that environment. I'm not trying to get too much caught up with it. So what we try to do at Osmocom is we try to bring the knowledge and the methodology we have in dealing with security issues in the internet, we try to push that a little bit into the mobile domain. Right? And there are many other aspects that don't exist. You know, if there's a security bug in Mozilla, then it gets fixed in a couple of days and you get a software update and it works. How often does that happen with the baseband processor of your phone? Or how often does that happen with a base station of a mobile network? Quite often the deployment cycles until an update arrives at an operator, until they can deploy it, is like 3 months or even more to roll it out. There's no incident response system. There's no CERT or something like that even collects the information. People don't assign vulnerabilities unique identifiers like CSV numbers and all the other things that exist in the internet domain. They all just don't exist in mobile communications. So how can we actually do that? Well, we have to bootstrap the process and create our own tools to do that. We need detailed knowledge about the protocol stack, which, as I said, all the documents are there. It's just reading them, in quotes. We need the hardware, which we have managed. I'm going to describe in a couple of minutes. And we need the open source implementation of the protocols, which we have also done. So on the handset side, on the telephone side, how do you do that? Well, there are different approaches you can take. The difficulty here is that everything is completely proprietary. So you have a proprietary chip with no documentation, running a proprietary operating system, running proprietary software on top. So it's relatively hard, and there are no external interfaces except, you know, the keypad and the display. So there's no APIs or anything that relate to the cellular protocols. Some people have tried to do that in the past. There's a TSM30 project and MAD OS, and they never really were successful. Yeah, but we have been successful now with Osmocom BB. I'm going to say that in a minute. On the network side, you need at least a base station. And then from there, because the base station implements the radio interface. Everything else is software. You can implement that if you have time and knowledge. But the base station, you have to get somewhere. However, as I said, they're typically only sold to operators and so on. And luckily, in 2006, I found a couple of base stations on eBay. And I bought them. I didn't have time at the time. I just thought, oh, you know, cool GSM base stations, let's get them. And then for 2 years, I was too busy. They were just sitting somewhere in a corner of my apartment. And then 2 years later, in 2008, finally, I was able to find some time to play with them and to start to do something. And by the way, the price was something like 300 euros or so. So some people pay more for a phone than I had to pay for those base stations. It's not always easy to find them so easily, but it was just good luck at that time. Now, you need to understand GSM, which can be a bit of a challenge. The specifications are more than 1,000 PDF documents, which each a couple of hundred to more than thousands of pages. But over time, it's possible to gain some knowledge on it. And after you gain the knowledge and you write the code, you can actually work with the security. So Osmocom I have already introduced. OpenBSC now was the first project we started, the first software project, which basically takes that base station we bought on eBay and we attach it to a Linux PC. And then the software we wrote, we called OpenBSC. And that software can implement all the other parts of a GSM network. So by using a Linux PC with OpenBSC and that base station, you basically have a complete GSM network, and you can make and receive phone calls. You can register your phones to it. You can make phone calls. You can exchange SMS and so on. That supports a number of different such base stations by now. And it's actually used, it was just a research tool initially, but now it's even used in more than 200 production setups. So the quality of the software has improved, and some people operating real GSM networks are now using OpenBSC as part of the network. One of the first test installations was looking like this. In case you cannot really recognize it, it is a tree, and on top of the tree you have two small gray antennas. These are panel antennas, and this red is just some tape that glues it to the tree. And on the bottom, we have these big, large, white boxes. Each of them weighs 48 kilograms and is one of these GSM base stations that I bought off eBay. And then you have some cabling, and in a tent, we had a PC with OpenBSC. This was in 2009 at the Hacking at Random camp, a hacker camp in the Netherlands, and we had an official license from the regulatory authority in the Netherlands to operate our own GSM network there, and we did so. And of course, then you suddenly you're an operator. You can see all the things that normally an operator does. You can try to find out the location of the phones. You can do all kinds of things and experience what happens. Well, then after that, we went to packet access, GPRS and Edge. There are some elements, network elements that you need to implement to provide packet networking to be able to have IP traffic over mobile networks. We implemented that. The implementation quality is not as good as that of OpenBSC yet, but you can now also operate a GPRS and an Edge network just based on a BTS and a Linux PC and open source software. Then we went to the mobile phone side and tried to also have an open source implementation of the protocol stack on a phone. Now, originally the idea was to build some completely custom hardware, but of course it's a lot of work and you spend a lot of time in prototyping and so on. And then you have the problem that maybe the hardware doesn't work, or you have some bug and you have already shipped hardware and so on. It's not so easy as doing software development. So we chose to use some old phones, Motorola phones. I'm showing you the PCB of such a phone below here. We reverse engineered that hardware. We removed the original software of Motorola and Texas Instruments, and we rewrite that protocol stack that runs inside the phone. So you can use such a phone now and connect it over a USB cable with your PC. And then the phone just acts as a stupid transceiver between the radio interface and your USB cable. And the entire protocol stack, layer 2, layer 3, mobility management, call control, SMS, authentication, everything runs on your PC and in open source software. And you can see really each and every message, each and every transaction. You can start Wireshark. You can see each and every of the messages that get exchanged on the radio interface. You can see what happens in cell reselection, in handover. You can really see what's going on, and you can influence it, of course. So there are many things, for example, what operators can do to find out where your phone is in order to do a location, basically find out the location of a phone. And a lot of it is based on timing. And you can, of course, if you control the phone by open source software, you control the timing. You can make yourself appear further from the base station than you really are, or you can make yourself appear closer because you fiddle with the timing. And this is the kind of fun things you can do. And this is now both OpenBSC and Osmocom BB is now used in a variety of organizations that do research all over the world. Even there are a couple of German universities, of course, because we are almost all of us are based in Germany that work on this. But also there is, in Brazil, in Cameroon, everywhere people are using this now for teaching and for research. Now, after we had done GSM, we moved further and we thought, well, there are other communication systems out there. One of it is TETRA. I'm not sure if how many of you have heard of TETRA. It's used as a police and emergency services radio system all over Europe. It's also used by a lot of private entities like airports or harbors, large container harbors. We implemented a software-defined receiver for it, plus protocol stack for the receive side and Wireshark dissectors. So now you can basically use I'm getting to the $20 USB device, you put it in your PC, you start the software, and then you see all the TETRA messages in Wireshark and can explore what's going on. And the funny part is that in Germany, it seems only the public police network uses encryption. All the other networks, even on airports and harbors and other things where you would say this is security critical, it's completely unencrypted, and you can just listen to all the communication or do that. Now, another system that we recently looked into is GMR, Geo Mobile Radio, which I guess nobody has ever heard. Some people may have heard the term Thuraya. That's a satellite telephony system which works almost everywhere on this planet except the Americas. So Asia, Africa, and Australia and Europe is covered. It's based on GSM on a very high level, but has lots of satellite-specific additions to it. But now we have also a receiver for it and partial Wireshark dissectors for decoding all the protocol. The little bit of encryption that this system has been reverse engineered and has been broken. The only thing that's still unknown is the speech codec, is how actually the speech is compressed, which is proprietary in that system. Nobody has fully reverse engineered yet, but people have made is they basically were able to read out the DSP ROM code of a phone and run that same ROM code, copy it over to a DSP development board and run it in that DSP development board. And then you can send the compressed audio that you have captured off the air, you send it to the DSP development board, and it decodes the audio and plays it back. So that has been covered as well. DECT, Digital European Cordless Telephony, is another system that uses communication over radio waves. Even before Osmocom was around, I was involved with a project called DECTed.org. It's a word game, of course, and it's not detected, but DECTed. And it was pointing out a number of security problems in these cordless telephony systems, so basically that you can eavesdrop on your neighbor's cordless phones. And some people always have the assumption just because something is digital, it's more secure than analog. Because it's analog radio, of course, you can just use an analog radio receiver, you tune to the right frequency, you select AM or FM, and you can listen to it. But with digital, it's not really all that much harder. It's just a little bit different skills and a little bit different tools that you need. But fundamentally, the fact that it's digital doesn't mean it cannot be intercepted. The Osmocom DECT project now integrates with Asterisk, so you can even build your own DECT base station. Then there's another project, OP25, that's the APCO 25 project, which is emergency radio for police and rescue in the United States. That also has been implemented on the receive side. So again, based on open source software, you can receive and decode those radio systems. And finally, we also started to do some hardware ourselves for the radio frontend. Because while you can do a lot of the demodulation, decoding, and so on in software on the PC, of course, you always need some type of hardware to actually capture the radio waves and get them into your PC. And there are some devices like the USRP that maybe somebody may have heard of. It's a universal software radio peripheral, But, well, you know, even the smallest and oldest one still costs you about $1,000. It's not the cheapest thing to buy if you're just doing this for fun. So we created this Osmo SDR, which is a small board. Sorry for the poor picture. It's a small board, has an antenna socket on the left-hand side. It has a USB that you can barely see here on that side. And you can use it to receive any frequency between 64 megahertz and 1.9 gigahertz and feed that into your PC and then use all the software for demodulation and so on that I spoke before. It's not a finished product right now. We just have developer units, but when the firmware is more user-friendly, we will actually sell it as regular devices, and I think the price point is about $200 or so. And there's an even cheaper option, which is the Rtl Sdr, which is a really, really cool hack. I personally think it's the greatest hack of the last year. What you see is the board that's inside a consumer DVB-T receiver. So DVB-T is digital television, and you can buy them for like $20 or 20 euros in Europe at random stores, and you just put them into your PC, and they're intended for TV reception. But it turns out you can instruct them to disable the demodulator and disable the MPEG decoder, so you get the raw samples from the tuner chip into your PC, and USB 2 is fast enough to do so. So you can, with a $20 device and the Rtl Sdr software, you can actually do almost the same that we did with our $200 device. Well, the quality is, of course, a bit different, but still, yeah, you just need that $20 receiver and antenna, and everything else is software at that point. So we are really at a point in time where doing anything with radio is so incredibly cheap and simple because it's all software, and the hardware you need is very, very cheap and consumer-grade equipment right now. Another thing we built is a SIM tracer, which is a device that this is a mobile phone on the left-hand side, and you put a flexible cable instead of the SIM card. You attach it to this device, which is the SIM trace, and you put the SIM card into the SIM trace. And then you can trace and intercept the communication between the phone and the SIM card. And again, feed that into Wireshark. We have Wireshark dissectors for SIM cards and for USIM. We wrote them. They're all mainline in Wireshark now. Which is, well, again, interesting to learn how these systems work. But secondly, also you can, of course, manipulate that communication because this interface is neither encrypted nor authenticated. So, there are some interesting things you can do at that point. Yeah, so this is a small hardware that again, we did. And by the way, I'm just pointing it out since we are here in Bulgaria, and I know that somebody from Olimex is also here. He's actually back there, out there. So we started with Olimex development board to prototype this, and then we made a custom board for the SIM tracer. So I'm very thankful that we have these inexpensive Olimex development boards. Another thing we did is an E1 transceiver board because a lot of the classic telecommunication in GSM networks is on a physical interface called E1. It's not Ethernet. So we built a small device for also interfacing that E1 line. And there are many other programs that over time have accumulated, which are more in the core network, the core network of GSM for SS7 and MAP and TCAP and so on. That has been implemented in Erlang. Some of you may have heard about this weird programming language. I'm somebody who is, I do hardware design, I know assembly of a couple of processes, and I do C development for, 20 years now or something. But higher level languages to me are always strange. But in this case, we actually used Erlang for those implementations for a variety of reasons, which I cannot all outline here. There's another project which is not part of Osmocom, which is OpenBTS. That's basically, when we created OpenBSC, we used a BTS that we could buy from Siemens. It was on eBay, it was cheap. But OpenBTS basically now uses these inexpensive software radio hardware devices and then runs even the BTS in software. So it's yet another step into making everything software and commoditizing the hardware. So you don't need a BTS hardware anymore to do that. There's another thing called air probe that's for air interface interception of GSM. So again, you can feed the GSM messages into Wireshark and do protocol analysis. After all that had been done, we also started a company which is called Osmocom, Systems for Mobile Communications, and that now is building products based on all the open source implementations that I indicated before. But all the software we do is, again, open source, so there's no proprietary software involved at any point in time. So, well, where do we go from here after all that journey? Some people, like Rtl Sdr, one of the colleagues in Osmocom project, he has been working with 3G hardware, not just GSM, but actually UMTS and HSPA devices. And as it turns out, even today, you can go on eBay and you can find Node Bs, which is how the base stations are called for 3G and 3.5G networks. You can pay something like 800 euros and you get an entire 3G base station. That's normal. The new price is probably 14,000 euros, but some people on eBay, I don't know where it comes from, are selling that surprisingly cheap, and it's actually new, so it's originally packaged. You know, it's not, you know, it doesn't look like somebody has stolen it and cut off the cables or something like that. So, and it's an official company. You get an invoice with VAT and everything. So. Yeah, maybe it was stolen before the rollout. I have no idea, but I get an official receipt with you know, with VAT and everything. So I presume it's not an illegitimate source. Yeah, so he's been playing with 3G networks and trying to reproduce what we did with GSM, also with 3G. But that's of course a steeper curve. Yeah, we also try to work with 3G phones and try to work on the phone side with 3G, but it's much more difficult than GSM. There are also some femtocells in some countries. Operators give femtocells out, which are small cells that people put in their homes to improve cell phone reception. There's been a lot of research on cell phones to use them in creative ways. You can turn femtocells into IMSI catchers and likewise things. Yeah, so finally, I'm getting to my call for contributions, where I say that, well, researching TCP/IP and internet protocols is boring. Everyone has been doing that for 20 years. And I would like to encourage, more. No, I'm saying everyone, you know. 20 years ago, it was not everyone, but now everyone is doing that. Everyone is publishing papers about that. Everyone, it's such a boring topic. There are so many other communication systems out there which are used by an equal amount of users and which, in terms of technology, lag 10, 15 years behind what is present on the internet, because the industry is a different one. All these systems that I've been speaking about, they are produced and developed by electronics, by hardware manufacturers. It's not the software industry that's creating and pushing these things, right? The internet world is dominated by the software industry, but all these other communication systems, they're dominated by electrical engineers. And they don't know, as I said, they don't know about incident response. They don't really know about software security. If you look at these baseband processors, you know, all the features that we have on a PC, like non-executable pages, address space randomization, and all these things that we have in terms of IT security over the last decade or so, they don't exist in these systems. So you can do buffer overflows like it was possible in the 90s on a PC. On the phones, you can still do it today, because there's such a disconnect between what the computer industry and what the electronics industry is doing. I think it's time that we give a little bit of pressure on that industry to improve their designs and the security of those designs. Okay, couple of thanks, and that was it. I know it was a lot of information. It was very dense, but it was just supposed to introduce the project, and of course I'm very happy to respond to any kind of questions you have, and I can go in more detail, explain something. Okay. Questions? There is a question. Yeah, I think there are microphones, indeed, and somebody is very sportive to bring the microphone.
Have you found any substantial bugs in the proprietary implementations of the communication stacks? You mentioned that there are only a few such bugs.
Yes.
Now you can modify the traffic from and to those devices. Have you found any?
so the question was, did I find any significant bugs in? Yeah, no, well, it was mostly other people, but in the team, yes, there were some discoveries. And based on what we built also, I think the most impressive demonstration, practical demonstration that I've seen was by a guy called Ralf Philipp Weinmann, a German guy working for the University of Luxembourg. And he's a security researcher there. And what he had demonstrated at multiple security conferences is how to turn a mobile phone into a remote spying device. Basically, how can I say, what everybody was afraid of, but people were always thinking, you know, these are the crazy conspiracy theorists. No, it's possible. So what he did basically is he started his own base station using OpenBTS and then sending malformed messages to the mobile phone, causing buffer overflows in the baseband processor. And from such a buffer overflow, he was activating the automatic answer mode of the mobile phone. So the next incoming phone call would be automatically answered by the phone without giving any indication. The screen is completely blank. It doesn't ring. It doesn't show you there is a call, nothing. It's because in the baseband processor, the next call was automatically answered. The application processor that runs all your user interface did never get any indication that there was an incoming call or something like that. And that was demonstrated with, I think, an iPhone 3GS at that time. This is a couple of years ago. And it was demonstrated with, at that time, some HTC, I'm not sure what it was, an HTC Android device. But fundamentally, those flaws, they're not specific to certain phone models, but it's, you know, it's all this. GSM technology was developed in the 1980s, the specification. First deployment, 1991. And still today, we are using that. And the implementations are also that old. People who have written code in the 1980s or 1990s, they did not think about IT security. You know, buffer overflows and format string vulnerabilities and you know, heap attacks, and maybe it did exist, but it was not something that people generally considered when they did implementations. So that definitely sort of was a very good practical demonstration of what can be done, only because there are such bugs in this technology. Okay, questions? Yeah, exactly.
What platform do you recommend for GSM debugging, testing, and stuff like that? So, for example, I have a GTA 03 free runner device, which has some problems running Osmocom. There's a separate branch for it, which didn't work very well the last time I tested it. What would you recommend for GSM work?
Well, it always depends on what you're looking or what you want to look at. But if you want to play with something that generally is a phone, and you want to try to send, you know, some strange messages to an operator or something like that, then definitely Osmocom BB is the software you would want to use. And in terms of hardware, I would recommend one of these Motorola C123 or C118 phones. I think I have one in my pocket somewhere. Yeah, so it looks like this. You know, it's a really, really old, crappy, cheap phone. Costs about 20 euros, sometimes even cheaper. And that's the best supported platform from Osmocom BB. As you said, the OpenMoco GTA02, it can work too. It's the same chipset inside, but less people are working on it or using it for that kind of work. So maybe the support is not as good as, you know, something breaks and nobody notices it for a couple of weeks or months because very few people use it. But this type of phone is what I would recommend. And then you get one of these cables. And you connect it to your PC. And it's actually funny because this is an audio connector. And you put it into the earphone, into the earphone socket of this phone. There's no USB port, nothing. This phone is so simple, it doesn't even have USB. So this you put in the audio socket. And the funny part is you can actually switch this from being an analog audio to a UART. So you have a UART over an audio connector, and you put that into your PC as USB. It's, I think it's fun. Okay, questions?
Two things. One, first, in which areas you expect people to help you?
Oh, there are many areas where help would be appreciated. One of the areas that are not really related that much to mobile communications, because of course there's a big, how can I say, to a lot of people there is this big unknown, all these GSM protocols nobody understands and it's hard to and so on. But there are other areas where we also could use a lot of help. So for these phones here, for example, what we do right now is we connect them to a PC. And most of the software we run on the PC, and only the lowest layer 1 implementation we run on the phone. It's not that we couldn't run everything on the phone, it's just it was easier to develop this way. But what would be fun is if we could actually run all that software inside the phone, and we can cross-compile everything for ARM, and that's not a problem because there's an ARM processor inside. But then somebody would need to make one of these user interfaces, for example, for scrolling through a menu or entering a number, and so on and so on. So this basically ARM embedded development on a small microcontroller with little RAM and little flash. But you can use a C compiler, and you have to directly talk to the hardware. So that's stuff that is not so not so special knowledge like GSM protocols. But that's an area where so if you're familiar with microcontroller development with an ARM processor, for example, that's something that would be very useful to get contributions in that area. Because then eventually we could actually use this as a phone standalone without anything attached, but running 100% free software on it. And I think that would be really cool. And by the way, it would be the first phone that Rtl Sdr could ever use. I mean, mobile phone.
And because the other thing, did you find these things by accident, or you have documentation about that?
We have some documentation, not everything. There are some leaked documents about the chipsets in this phone, which makes it much easier than with other phones. Also, schematics have leaked from Motorola about this phone, so this makes it really very attractive to use those phones. And they're cheap, so if you solder something and it breaks, well, okay, it's just 20 euros, get another one, But if you tried it with an expensive Android phone, it's like, oh shit, 500 euros, That's a different problem.
Hi.
Yeah.
So I was wondering, on a higher level, do you think this parallel development, because I understand it happened alongside the internet, do you think it's justified? And how would you grade it? There is the end result of software and specifications from the telecoms. How would you grade it at the technical level now that you have dove so deep into it?
Well, I think it's a lot not invented here syndrome. So it's basically the telecom industry, they're their own club and they don't like to do anything that's not what they have invented or what they have come up with. And there's a lot of disconnect. Also culturally, I mean, if you go further back in the history of the internet, you see that as well. There were the large telecommunications companies which believed in circuit switch networks, not packet switch networks. And they wanted to create the ISO OSI networks and X400 and X500 and all these systems, which, for example, in Germany, German universities for a long time did not connect to the internet because they thought TCP/IP, this is this, this crappy stuff, it's not following any ITU specifications, it's not what is going to be the real packet switch technology of the future. So they were always waiting for the telecom world to come up with their own protocols. But then, everything has changed and the internet became what was successful, and nobody has ever heard of these ITU protocols for packet switch networks anymore. So I think it goes back maybe at least into the 70s, if not the early 60s historically, this kind of disconnect. On the one hand, there's the pragmatic internet people who, everyone can participate in the IETF, everyone can write an RFC or a draft for an RFC, everyone can discuss and can contribute. Completely open development model versus the telecom industry where you need to be a company, you need to pay a lot of membership fees, and everything is formally voted on, and there's political games and political influence and so on. So it's a different world that we see here. It's changing now for future technologies. I mean, if you look at LTE, for example, it has changed quite a bit. the 4G technology. But still, on the lower protocol levels, you have all this telecom mindset and telecom tradition. But it's getting less. It's getting less.
Hello. I was wondering, how many years do you think it will be before Nokia or Siemens turns into like the transitions in the way that IBM transitioned from a proprietary company to a company that supports open source? How many years do you think we're at between Nokia becoming more of a support company as opposed to a software development company?
That's a good question. Well, okay. On the handset side, I would say, well, Nokia is dead anyway. I mean, okay, well, they get a little bit of money from Microsoft here and then, and it will continue. Maybe Microsoft will buy them eventually, and that's what will keep them alive. But on the handset side, I wouldn't expect much from Nokia itself. On the network side, Nokia and Siemens have merged. It's now called Nokia Siemens Networks, NSN, and they are losing a lot of money and had to let go a lot of people. The only two companies which on the telecom, on the equipment side, are still really successful is Huawei from China and Ericsson. And in those companies, I really don't think we will see, at least I don't really predict such a change to happen. It's a very different mindset and a very different, I don't really think it's going to happen. All of these companies are based on millions, if not billions, of lines of proprietary code and proprietary hardware and ASICs and programmable logic and so on and so on. And it's very hard for me to imagine that they would move to a model where they would use do more support and move away from proprietary software. I think it's unlikely. But, well, I always like positive surprises. Yeah, I'm pessimistic.
Okay, thank you.
Well, thank you.
And you get a bottle of dry white wine.
Well, thank you very much. You like positive surprises, right? Yes. Who doesn't?